Hello friends, welcome back to my channel. And in this session, in this video, we are going to talk about the embedding step in the RAG. So we are going to go in detail. So before that, just to recap, so in this channel, if you see the playlist section, this in this playlist section, AI generalist, in this playlist section, I started with this basic RAG related videos. So how to start the RAG, so data collection and then data reorganization, then data cleanup and cross source deduplication and chunking strategies, a couple of chunking strategies, and the last one is the semantic chunking strategies. So after this, the step comes which is called as embedding. So let's start with the embedding. Okay, so let's start with embedding. So embedding, we will see some theoretical part now. Embeddings are a way to represent words, sentences, or even enter documents as dense vectors in a high dimensional space. Okay, so there are a couple of steps here. So semantic maps. So text is turned into numbers to represent underlying meaning. These are the internal steps. Relevance ranking. So mathematically finding the best context for any user query. Knowledge retrieval. So the bridge connecting stored data to the language model. That is part of embedding. Just to have a graphical representation, so there's a high dimensional space and the semantic maps, relevance ranking, and knowledge retrieval. These are the graphical representation of the concept. Okay, so the embedding model. Now, so we have seen what is embedding. Now let's come to embedding model. So in AI world, in when we want to actually implement something a RAG, then we need to choose an embedding model. So what is an embedding model? It converts the text into numerical vectors that captures semantic meaning. So there is a translation tool, there is a semantic anchor, there is a retrieval engine. So this is bit theoretical aspect and we need to see only once so that we will understand the gist of it. So translation tool so converts text into numerical vectors for computer processing. Semantic anchor places similar meaning closer together in a vector space, and retrieval engine enables the system to find the relevant context for queries. So these are the things which are going to help us in better implementing the RAG and retrieval, storing the data, and many other places. Okay, and what is the embedding model architecture? So there are a couple of steps here. So input tokenizer, transformer layer, pooling layer, normalization stage, high dimensional output. Okay, so tokenizer, yes, straightforward. It will breaks the raw text into smaller meaningful tokens. Transformer layer so captures the deep contextual relationship between words in a sequence. Pooling layer so compresses hidden states into a single fixed length vector, normalization step, and high dimensional output. So we can go through this theoretical part just to have a visual representation. So this will have a couple of things: embedding model and then embedding model architecture will have these kind of steps. Okay, MTEB. So MTEB is a major concept in embedding. So massive text embedding benchmark. Embedding is a standard leaderboard uh, and evaluation framework used to measure the performance of text embedding model across diverse task languages and datasets. So this particular uh, website or a portal or whatever you want to name it have maintained a very strong, very useful, and very popular leaderboard or dashboard where you can instantly see the required benchmarking aspects. Okay, so we'll see this. So this is the Hugging Face portal or a website where we can clearly see the uh, general embedding leaderboard. So which embedding model is useful for whatever particular need or particular aspect. So typically it is multilingual and let's say it is text based. Normally many of the projects in the RAG are text based. We can also go for image based. We can also go for audio based embedding model, and these are the other domain specific and language specific. So in the language also we can see European, Indic, and Scandinavian, Chinese, and other languages. So those kind of segregation is also available. So the point is at one place, lot of things are available for us to evaluate which is the best model for our particular need. Okay, right. So Let's do a simple thing. So we can say these are the couple of models. Okay, and what we can do is we will just simply sort it by descending order. Okay, let's ascending order. Okay, so if you see this voice 3.5 zero shot, uh, zero shot, zero shot programming or zero shot prompt is almost giving you 100% results. The one what we wanted. Of course, there are many other aspects here. Um, we will see the one which is the couple of things we are going to actually see a demo. Um, okay, maybe this one. So all mini LM L2 V2. So let's see this. Okay, so for this particular embedding model, these are the factors, and if you see they downloaded last month and those things, so it seems it was a bit popular, and last month only because of lot of whatever situation, these downloads were reduced. But apart from that, there are many other things what you can consider. There's a sample code and so on. Okay, right. So that is about this. Then this is also available on GitHub. Okay, so this is also available on GitHub, and here we can simply install a pip library and we can get started. Okay, so there are a lot of things here. We will be seeing this overview and benchmarks and model. Okay, then next one is, yeah, this one, available benchmarks. So let's say we choose a particular AI model, embedding model. So what are the benchmarks? Why it is popular? Why people are still, people still want to use it. The developers still want to use it. So there are a lot of benchmarks available here, which we can go through. So let's take one for text model, and let's take some random. Okay, so BM retriever, BM retriever 1 billion parameters. So if you see, it can have almost 900, 1 billion, 908 to 1 billion parameters. Um, Embedded dimensions, max tokens, it can take 2K tokens, memory is 3.4 GB. It was released 2024, and language. Okay, and many other things. Okay, so we can search for the required model, and we can see the benchmarks, based on our requirement, based on the benchmarks also we can select a particular AI model. Okay, so we have seen the text based. Now let's take this one, how to choose the right embedding model. So there is this uh, small article also which you can go through. The link is there in the description, which you can go through. We are going to discuss anyway the other parts also. Okay, so filtering models based on the criteria or need. So that's what we have seen here. So if you see here what we can do is we can filter as per our criteria, or there is a search also available. um, okay, so there is a search here, models. Okay, the same thing. So this is where we can search for the model. So let's say uh, nomic AI. So this is the one I have used many times in my earlier videos also. So this is the one where we can search. Then, right. So embedding model evaluation. So this is also one of the very important step. So now we have a lot of AI embedding models available. We evaluated couple of tentative 2 to 3. So how do we evaluate? Okay, and again, there are many places where this evaluation framework is available, but I am going to discuss a couple of things. Yeah. So domain relevance. Yes, are you using the right tool for the job? Okay, so let's say if you are doing some, some rag about the legal documentation. So for legal documentation, obviously you will not choose something which is for medical related, and vice versa. So for medical related assistance or rag, we will be using, let's say, PubMed Bird or BioBird, and for legal we are using legal bird, and similar. So we should use the AI model, the embedding model, according to relevance. Then performance on retrieval task. Okay, does it actually work? So fine. So we have chosen a good model. It will do, you know, store the data and do proper embedding. But then what about retrieval? So retrieval performance also matters. So key metrics to evaluate the retrieval task or the performance of the retrieval task. So recall at the rate case. How often does the correct document appear in top key results? Okay, MAP, mean average precision, NDCG, normalized discounted cumulative gain. Okay, so there's a couple of parameters we can talk about it more. So I have a demo also, so we'll see some basic thing. Okay, embedding size and efficiency. So bigger isn't always better. So many embedding AI model claim that okay they can take up to 2k token, 10k tokens, and whatever. That may not be good all the time. So we need to see how optimized the way the token can be handled, how we can improve on the tokenization, and we get our job done. Okay. Now, some other evaluation points. So, multilingual support. So, does your model speak right language? Okay. So, yes, typically, let's say English is preferred, but then if you are going for other languages, European languages and all, do you really need that support? And does the AI model, the embedding AI model, supports it? Okay. Um, Open source versus proprietary models. So again, that matters for budget versus performance. Yes, open source models are many available, but then again, the question is proprietary model will have faster and effective, and some pre-biased responses which are helpful, which will save time, cost, and other factors. So that is also one of the evaluation model parameter. Okay, self-hosting BG embedding, suitable for startup and budget constraints. So we can have self-hosting where we can host the AI model, the embedding AI model locally, okay, on our system instead of on the cloud. So that will have their own advantages and also disadvantages because it will be 24 hours on. So there is a budget and performance consideration. Okay, so in our example, we will be doing something which is on local. Okay, so there we will see the difference. OpenAI embeddings suitable for a large scale SaaS application. Okay, based on popularity, based on uh, typical research. So these are the top five open source models. Okay, embedding models. So yeah, there are many models which we can see the MTB score also here and the cost and other things. Okay, this is the open source model. Right now, to give a demo because I don't have access to paid OpenAI and those things, so I'll use something which is there for Olama. Okay, so by the way, I'm using Olama uh, on my local. I've installed it, and there is a good amount of credit which I have been given that too for the initial phase, and I'm sure for many of the practical reasons it will not exceed. Okay, so the credit will be there for uh, long period. So I'm running the Olama on my local, and I have logged in also. So for Olama based embedding, there also we have lot of freely available or locally installable embedding AI model which we can use and solve our purpose, or actually, or maybe we can give it a try, trial something. So BGEM3 576 567 million parameters, best used for hybrid search and key strength. So we'll see BGM3 Quen embedding, MX by, and nomic embed text. So these four things we will see, and uh, we will see actual demo also. Okay, I encourage you to also explore other things for whatever use case we have, and sorry, your purpose. Okay, so let's see a demo. Okay, enough about the theoretical part. So we will see BGM3 okay, BGM3. So this is the full form. It is multifunctional, multilingual, and granular. The key factors, yes, instruction aware retrieval. So this is one of the very popular Olama based model. The key features are instruction aware retrieval, massive context window, okay, up to 32,000 tokens. Matryoshka representation language is again one concept probably we'll discuss in later videos. So this is also used in embedding model. Model scaling available in three optimized sizes. Yes, so we are using this for demo. We are using the 4 billion parameters model. Okay, right. Okay, so we'll be using this BGM3. Right, so I have this sample code. Okay, and as I said, I am running the Olama. I have logged in and I have downloaded that model. Uh, okay, so if you see here, I have this nomic embed mx by embed coin 3 embed. These are the four, yeah, BGM3. So these are the four embedding models available on my local, and we will be seeing a local demo. Okay, so what we are doing is simple. We are calling the Olama method embed, and we are giving one input, and we are going to see the embedding and the tokenization, right? So I mean, output is a list of how many dimensions of vectors. Okay, just for one line of input. Okay, so let's see. Now, because it is running on my local, it might be a bit slow, but of course, when we host it on a high speed and high RAM system, this will be faster. Okay, so the sample values are this thing. This is expected. The embedding dimensions are just for one sentence. This is considering 1024 1K direction dimensions, and these are the first five values. Okay, right. Let's see. So the practical aspect is we need to have uh, optimum set of direction, optimum number of directions, not more, not less, and the sample values should have these numbers, right? So remember the thing is that the main concept here is to convert the text into numerical values, and then we can process further. Right. So now next is Quen 3 embedding. So this is about Quen 3 embedding we discussed already. So Quen 3 embedding is also one of the very popular, recently very popular uh, AI model, embedding AI model. So for that also we'll see a demo. Okay. So again, this Olama based. Everything is Olama based. I have to pass the 4 billion parameters, the local AI model. Okay, so there is an input text, there is an instruction, and there is a query. It is about some medical stuff. Okay, medical domain, and we'll also see the embeddings and how many directions and dimensions it is considering. Okay, so 2560 dimensions it is considering, which is very good when we say it is a popular uh, AI model. Okay, right. Next we will see MXBI embed large. So same thing. We'll just have a query and then pass the model name. Okay, so queries represent the sentence for searching relevant passages. What is the weather? Okay, so let's see. Right. So if you see again, the embedding expected is 1024 dimension, 1024 directions, which is also uh, considerably good. Okay, and now let's come to the nomic embed text. Okay, so it is having 768 dimensions. So this is also widely used. I have also used this in my earlier videos also, as I said. And okay, so before that, we'll see this one. Yeah, MXY embed large model. So state of the art performance, top tier performance for on the MTEB leaderboard with 335, just 35 million parameters, and that too it is on the top tier, which is quite good achievement. Matching much larger model, right? Yes, again, Matryoshka representation learning embeddings can be truncated into 512 or 256 dimensions. So in we can truncate it, and that is will increase uh, will reduce the processing cost and time, and of course there are some trade-offs. Okay, so while retaining the 93% performance, so this is also good. You're reducing the dimensions or directions, but then you're still retaining up to 93% performance. That is why it is bit popular. Okay, allowing for flexible search efficiency, optimize retrieval and efficiency and size. Okay, and it can dig deep into it. So MX by we have seen already demo, and And next is the nomic embed text model. Okay, as I said, it is highly popular open source embedding model series and available in Olama. Okay, known for its efficiency and massive context window. It was the first fully reproducible model to outperform OpenAI. Okay, OpenAI's text embedding ADA2 ADA002 AI model. So this nomic embed text competed and outsmart this OpenAI's model while remaining significantly smaller and faster. Okay, so that is what matters. So competition. Right. So key features of Nomic Embed Text version 1.5. So 8K token context window, MRL supports variable embedding dimensions. Okay, we can reduce the dimensions. This allows you to truncate vectors to save up to 12x memory. Okay, also one of the good achievement with minimal accuracy loss. Fully reproducible, Nomic AI released the weights, training code, and curated training data, making it one of the most transparent model for production use. Okay, fully reproducible. Multilingual, uh, multimodal latent space. Okay, right. So okay, so we will see this demo also for the Nomic embed text. So input is simple. Nomic embed text is an open source long context model. Let me run it again, and if you see how quickly we got the result, okay, so we got the result very quickly. The dimensions are less, 768 as we have seen in earlier 1K, some different language, a different number is there, but here it was a bit quick. Okay, so like this, we can evaluate the embedding AI model for our particular need and get the job done. Thank you. So if you like this video content, please like, share, and subscribe to this video channel. Thank you.